Welcome students to a colorful part of this chapter in the sense that we are dealing with different effects of refraction and very beautiful effects. In fact, very beautiful effects. And this particular section starts with how we get various colors from when white light is passed through a prism. Now, the process involves refraction as well as dispersion, and we'll be looking at the whole physics in quite a detail. So it's basically the dispersion of white light by a glass prism. Now you are keeping a glass prism, and when a ray of incident light is allowed to pass through it, white light, it should be white light, and it is allowed to pass through it, what happens is that the emergent rays actually consists of a spectrum of color. So what exactly is happening now? So this is white light, and as it touches the surface of the prism, naturally there is refraction, and what happens is that as white light consists of 7 different colors, it's actually the colors basically means that particular light stream, that particular colored light stream has its own properties. The reason by which that's the reason why it's getting split at different angles when compared to the incident ray. So you can see that it's a red. The part of the white light which consists of the red light hasn't got that much deviation, but if you look at the other side, at the other end, the violet part of the white light has the maximum bending, or has the maximum dispersion. So this group of colors is what is called a spectrum. Right? A spectrum is the band of colored components of a light beam, and the spectrum you are getting is can be shortened in the form Vibjov, that is violet, indigo, blue, green, yellow, orange, and red. So here there is a refraction, and as soon as the light is getting refracted, because the white light consists of component colored parts, it is getting dispersed, and it is getting split, and so that process is called dispersion. So after refraction comes dispersion. So dispersion is a splitting of light into its component colors. So why is it happening? As I already told, each color has its own. Each colored part of the light has its own properties. That's why it's getting split. So different colors bend through different angles with respect to the incident ray. And now a very important point: it's the red light which is bending the least in the whole spectrum, and it's a white light which bends the most. And red light is bending the least. It's a pointer towards one of the important properties of why we use the red color, the red light as for signaling, and so that it will be covered in other sections, but that's an important point here. Now let's look at some very interesting experiments done by the famous scientist Issac Newton. So he was the first person to use a glass prism to get the spectrum of sunlight. So he did basically 2 types of interesting experiments. In the first experiment, he kept 2 prisms. So you have a prism, so he kept 2 prisms in the same manner. There's something like, so 2 prisms in the same manner, and let sunlight through it. So naturally there was refraction, then there was dispersion of colors. That dispersed colors again dispersed colors that passed through the second prism, but nothing happened. He only see the same colors coming out as the emergent rays through the second prism. Now the point that these 2 prisms were of the same kind, so that's very important. But when he did another experiment where the first prism was put like this, and the second prism was actually the other way around, that is, it was put like this. So it was inverted. Not that the 2 prisms were of the same kind. What he saw was that of course there was dispersion into colors in the first prism, and when the dispersed colors were passed through the second same kind of prism, but here the second prism is inverted. He got a white light out. So from this experiment, the conclusion he got was that sunlight is made up of 7 colors. So it's this 7 constant colors, colored lights joined together, or is something like together forms the sunlight. So that was the conclusion. Now note the point that so any light giving a spectrum which is similar to sunlight is called white light. So there's a definition for white light. White light is defined as a color which should constitute these 7 colors. So that's the meaning of it. So white light is white light should be similar to sunlight. Going on to another very interesting, very colorful, something which we always are interested in seeing, something which is one of the wonders of nature, is what we know. We all of us have seen it sometime or other. It's the rainbow, and rainbow is interestingly the physics of rainbow is dealing with is quite similar to what is happening in prism. So now usually after you see a rainbow, usually after rain, which simply means that there will be a lot of water droplets in the atmosphere. So here's a water droplet which is suspended in the atmosphere, which is something like a small droplet which hasn't fallen down. It's suspended in the atmosphere, and you have the sunlight coming in, and here obviously this round shape, it's a representative image of the water droplet. At point A, there's refraction, and then the dispersion happens. That's understand that from point A to B and C, here what is happening is just reflection. So there's first a refraction, then there's what is called internal reflection, because it's just at point B that light which is coming into the droplet is getting reflected, nothing else is happening. But at point C, actually there's another refraction and the colors are coming. So you can see that there are 2 refraction happening at points A and C, and B it is basically a reflection. So at A, the light is refracted and the sunlight, the colors are dispersed. So AB and BC, there's 2 rays. Basically this is the incident ray which is reflected. This is the ray inside the droplet which is reflected as BC. And at C, there's a second. So note the point inside the water droplet, there's 2 points of refraction and a point of reflection. So it's refraction, internal reflection, and a second refraction. And a very important point, rainbows always are seen always opposite to that of the sun. Obviously, why? Because the sunlight should be, the sunlight should be something like coming and hitting the water droplet in such a manner that you should be standing in front of the drop. So suppose this prism is representing a droplet. The sun should be here and you should be on the other side. So if that is the way you are seeing the rainbow. Thanks.